On December 13th, 2025, humanity made history, once again, but this time not on the moon. This time at the place that has given us life for millennia and could extinguish us in seconds. The Parker Solar Probe just accomplished the impossible, and I bet you haven't heard a word about it. The Parker Solar Probe, named after Dr. Eugene Parker, the man who theoretically predicted the solar wind back in the 1950s and was laughed at for it. He was right. And today, a spacecraft is flying through that very solar wind, closer to our sun than ever before. Let me show you what really happened on December 13th. The Parker Solar Probe just completed its 26th close approach to the sun. But this is no ordinary flyby. The spacecraft came within 3.8 million miles of the sun's surface. That sounds far, but it's not. Imagine this: if the distance between Earth and the sun were a football field, Parker Solar Probe would be just 4 yards from the end zone. 4 yards from a glowing ball of plasma hotter than 1 million degrees Fahrenheit. And here's where it gets truly impressive. To escape this inferno, the probe accelerates to 430,000 miles per hour. That's 195 times the speed of sound, faster than any Apollo capsule, faster than anything we've ever built. Let me put that in perspective. Remember Apollo 10, 1969, that was the fastest crewed spacecraft at 24,791 miles per hour. Impressive, right? The Parker Solar Probe is 17 times faster. Write in the comments, did you witness the Apollo program? I'd love to hear your stories. But why are we doing this? Why risk a $1.5 billion spacecraft in the hell of the solar corona? The answer might be sitting in your pocket right now. Your smartphone, your GPS, the satellites that give you weather forecasts. All of it can be wiped out by a single solar storm. Quebec 1989 wasn't an isolated incident. In March 1989, a massive solar outburst hit Earth. Within seconds, Quebec's power grid collapsed. 6 million people sat in darkness for 12 hours. Repairs cost hundreds of millions of dollars. Today, the consequences would be catastrophic. Airplanes without GPS, hospitals without power, communication satellites destroyed, modern civilization paralyzed. The Parker Solar Probe gives us something we never had: advance warning. It measures the source of these storms directly in the solar corona, not from Earth, not from a satellite, at a safe distance, right in the middle of it. And what has it discovered? Something completely unexpected. Scientists just released images this week showing that not everything ejected during a coronal mass ejection leaves the sun. Some of it makes a U-turn. It falls back. That sounds simple, but it changes everything. This returning matter reshapes the sun's magnetic field, and that reshaped magnetic field determines where the next solar storm goes. A few degrees difference, and the storm hits Mars instead of Earth, or vice versa. For the first time, we can directly measure this process: the speed of the falling matter, the size of the magnetic bubbles, the patterns that repeat. Parker is giving us the missing puzzle pieces. But that's not all. The mission has also created the first complete two-dimensional map of the Alpine surface, the boundary where the sun's atmosphere ends and the solar wind begins. This boundary isn't static. It grows, shrinks, becomes spiky during the solar cycle. This fascinates me. We thought we understood the sun, but the closer we get, the more surprises we find. What space discovery surprised you most in your lifetime? Apollo 11? The Voyager probes? Hubble? Write it in the comments. Now you might be wondering, how does this thing even survive? The answer: a heat shield made of carbon foam, 4.5 inches thick, designed to withstand temperatures of 2,600 degrees Fahrenheit, hot enough to melt steel. While the shield glows like lava, the instruments behind it remain at comfortable room temperature. Eugene Parker, the man the probe is named after, was there at the 2018 launch, 91 years old. The only scientist who ever witnessed a NASA probe being named after him during his lifetime. He died in 2022, but his legacy still flies through the solar corona. The mission is planned until 2026, but Parker keeps going. Every 88 days, it repeats its death-defying dance with the sun, collecting data, surviving the impossible. The next flybys are coming on March 22nd and June 19th, 2026. Same distance, same speed, same mission, understanding the sun to protect the Earth. From Apollo to the moon, now Parker to the sun. When you were young, we dreamed of flying to the stars. Today, we're touching our own star, and I mean that literally. Dr. Parker was ridiculed for his theory of the solar wind. 70 years later, a spacecraft bearing his name flies through that very wind, proving he was right. That brings me to my final question for you. What would you tell today's generation of space engineers? What did you learn from Apollo that still applies today? Or what should we do differently? I read every single comment, and I'll feature the best answers in my next video. Share your wisdom, share your stories. This young generation needs them. Thanks for watching, and don't forget, the next great solar mission is just around the corner. Clear skies,